I'm going to try solving a problem in Abaqus. Here's the problem. It's a rigid frame. Let's call it a frame. And here's Abaqus. First off, make a new model database. Can we close new? Come on, new. Ah, right, that's what I'm doing. Okay. Then second, create a part. Let's call it a frame. I don't know how to make a 3D solid, so let's make it a wire, because here it says cross-section of each member is square with area of 50/50. So we're making a wire, a 2D wire, not even a 3D wire. And the size is 1.5. 1.5. Let's make it 6. Let's make it 6. Let's make it 6. Okay. Draw some crap and then dimension it. Measuring doesn't even matter. It's harder to dimension everything. And hopefully it doesn't constrain things.
Sorry, I need some paper. Can I get some paper from the canteen?
Oh yeah, you betcha. What? So I paused. Apparently you can't change dimensions here. So let's erase it. And redimension. Where is CD? ABJH, ABJH, CD1. Down here, just click 1, and boom, done. Wait a second. Done with that. I made a change, so now I have to regenerate. Next step is, I guess, let's from memory try to go through all of this. Apparently you have to create a section. Or you know what, let's make a material. We're using Elgiloy. is elastic. Let's see what happens when we don't have a Poisson ratio. Poisson. Yeah, let's skip that and see what happens. Create a section, whatever that means. It's going to be a beam. Box, and let's call it Elgiloy. However that's spelled out. Oh, it's not a box. I made a mistake. It's a rectangle. We're using all SI units, so 50 millimeters, which is 0.05. Should be right. Poisson's ratio, you just ignore in this case. And now we have section 1. The orientation doesn't matter, so we don't need to. We don't need to assign any orientation. And I think there's a second way to assign orientation. And here, I think at the top, you might be able to change the orientation by either going through there or double clicking here. And it looks like from the top, this is the correct way to select orientation. Let's do that anyway. Orientation doesn't matter because it's symmetrical, fully symmetrical. Create a mesh because why not? In the student version, we're limited to 1,000 nodes. Let's use 1,000 nodes. Afterwards, you have to, for some reason, mesh the part by clicking here and clicking yes. You already have a section and profile. To create a new instance, don't know why, but apparently we do. Create a new step, which is, I guess, a time. This software is time-based software where we just have one applied force. So apparently, if I understand things correctly, this is like a three-dimensional kinematics simulation. We're constraining the feet. I'm holding shift and clicking. And apparently the legs are not the correct length. And we are fully constraining. Global. Incarstrating it because I think that means that the feet are just fully constrained. You see that U1, the movement direction is of U, and the rotation directions. Rotation degrees of freedom are fully constrained. So that's done. have to fix this. Apparently you can't overdefine things, so let's delete things. And that is correctly constrained. So we have a constrained structure, and now we're applying loads. First we generate. Did I suppress something? I don't think so. So let's generate some loads. So at node D we have a rightward displacement, rightward force. In the right direction, and it is 3 kilonewtons. That's the correct direction. We're also creating a moment at two kilonewtons at node C. Kilonewton-meters. Force displacement. What's the last one? At node B. Huh, that's funny. I don't see anything here. Well, I'll figure that out later. So the displacement is located in the boundary condition. Left displacement. Apparently you can't change the name. And it looks like things are finished here. So let's create a job. Unintuitively by double clicking, and well, I guess that is intuitive. And let's see if we could submit the job. Right click and let's see what everything looks like. Hooray. That is interesting. Let's look at the displacements. That doesn't make too much sense. In order to solve for all this information, only way that I see, the easiest way that I see is to query things. Either by clicking query here or information which is query there. You just click probe values and probe individual sets, individual nodes. I am pressing escape and using my touch screen. And those are the 6 points. Let's write that to a file and see what happens. So first, I like to erase the file, and then afterwards, write it to whatever file, whatever you want to name the file, and whatever folder you want. I just leave it as default. You know, I shouldn't leave it as default. So let's see what it looks like. Looks like this, and it's a big mess. This is a huge mess. And that's all. I find Abaqus very unintuitive. Hopefully this helps you.